My name is Floris. I've been writing Python for quite a while, and I've been starting to use Kubernetes for about 1.5 years, I think. I've worked with it since just before it became 1.0. And this is sort of a number of things that can make your life easier towards building your application more suitable for Kubernetes. Kubernetes is part of the Cloud Native Computing Foundation. That's kind of where the title Cloud Native Python comes from. And one of the things is like it's not really necessary to do all of those things. You can start without actually doing any of these things. As soon as you can Dockerize your application. You can run it in Kubernetes and can start benefiting. It's just a number of things you can start adding to your application gradually as you need them, as you want them, kind of thing. This is sort of the roadmap. So I'll go through very quickly, give a bit of background about how Kubernetes actually works. If you know Kubernetes already, that's maybe a repetition, but I'll keep it very small and simple. Then I'll sort of say on which parts of the execution environment that you get out of when you're running inside Kubernetes, that you can sort of rely on what shortcuts you can use. I'll talk about handling logging, and then I'll go a bit about endpoints and monitoring. So this is kind of my summary of Kubernetes, kind of. So Kubernetes inside of in one slide, if you want. So Kubernetes is actually it's an orchestrator for running your application on a cluster. So the idea is that you just have your process, which you wrap into a container. It's just your single Python process that runs in your container. Currently, that's basically means Docker. And Kubernetes will just make sure that your application runs somewhere on one of the machines in the cluster. Kubernetes refers to machines as nodes in the cluster. So you got your application, which is your process, wrapped in a container, and Kubernetes abstracts that away into a pod. A pod is basically got some extra bells and whistles. For this talk, you don't really have to worry about what else you can do with a pod. Pods don't really have much guarantees when they run on this cluster. If the node goes away for any reason, your pod goes away. Pods may get killed for other reasons because they start using too much resources of some sort or whatever. So they don't provide any consistency. So the next abstraction on top that Kubernetes sort of gives is the replica set. And the replica set kind of monitors your pod. And the idea is there that you should say, I want to have this many copies, I want to have one or whatever number of copies of my application, of this application running, and that will just watch your pod. And if your pod goes away for any reason, you create a new one. And that also allows you to kind of scale up as you get more load, you add more, you just say, oh, I'll give me more replicas, and more pods will run, and they'll run distributed over the cluster. There's some scheduler involved that figures out where the best place is for your pods to run. There's other abstractions other than replica set, but I'm not going to go into those. There's various other ways of looking after your pods, basically. But as concepts for now, that's kind of enough to sort of, everything is built around this concept, and a lot of them use replica sets. The other thing is, like, because your pods are so ephemeral, they just move around, they come and they go, you don't know which machine they're on. You need to be able to address them. So their IP addresses and ports, if you have a service that listens for incoming connections, need to be addressed. So that's where this service abstraction, the service object, comes in with Kubernetes. So the idea there is that it's basically kind of a level 4 proxy or load balancer, and it just it's fixed IP address, and for your pod that anyone in the cluster, there's normally a DNS name associated with that as well, so you can easily find it. And whenever you need to talk to to your service, you connect to that IP address, and that will route the traffic to wherever the actual pods is. If you have multiple pods, it will round robin between them or something like that. Again, there's more bells and whistles, but that's kind of, if you got those three things, you know enough about, in the basics of Kubernetes, kind of how Kubernetes manages things around. So brings us to kind of what you can do in your execution environment. So you're running in your application, your Python program is basically running inside this pod that's being looked after by replica sets, etc. And it allows you to kind of skip a bunch of boilerplate. Your audience is an operations team that knows how to handle Kubernetes. And also it means you can rely on the architecture for scalability, etc. So you can make your internal application actually a lot simpler, and you don't have to worry about it as much. One of the first kind of thing that I think is kind of useful is don't try and recover errors. If you get an unexpected exception, just make it crash your whole application. You'll probably be fine because your application is being watched after. So inside Kubernetes, you got a lot. All the operations is kind of done with a lot of YAML files. So if you've played Kubernetes before, you might recognize this. This is just a partial kind of view of that. So this would be some sort of way of defining your application to run. You have an image and some arguments. It's actually a bit, but the bit that matters here is the restart policy at the very last line. That basically ensures that whenever your application dies, it will get restarted. And that allows you to, when you have any unexpected conditions, your request data doesn't validate or something like that, you can just crash and you can rely on the infrastructure to take care of it. Again, it will be logged that the crash happened, and you have all the information to look at what went wrong. The one thing to think about is if you have a service that accepts incoming connections and processes requests that way, you do have to worry about when you crash what you're going to lose. So if you have a number of requests queued up inside your application, if you crash and you lose all those requests, they will start timing out, and that might not be as ideal. So you may want to think a little bit about your architecture there, and make sure that maybe use a messaging bus that to process your requests, so that when you crash, you don't lose all of those. So you have to look out a little bit for those. But yeah, otherwise, don't try and make your application too robust, really. And the other thing, kind of linking into that, is you can also make your application a lot easier. You don't have to handle a lot of scale. The idea is to scale via the process model, which means you just run more processes in parallel. And if you have a messaging system already to talk between your services, it's very easy. So as I showed earlier in the Kubernetes slide, the idea of scaling is just you create more of your pods with your application running into, and that means you not terminating the end user request. You should have a load balancer or reverse proxy. If you're handling HTTP traffic, you'll have a reverse proxy in front of that. So you're not handling directly the end user requests. So you can just, your internal architecture can be very simple. You just have a main loop. You handle one request at a time. You don't, and making this architecture that way means you don't have to worry about the scale too much, because the scaling is done on a different level, really. Yeah. So. Next on, I think it's useful to say a little bit about logging. So again, kind of on a very simple level, if you've ever played with Docker or Kubernetes, by default things go to standard out. If you're the main process in your container, and I would recommend to just run one single main process in your container anyways. Then anything you write to standard out or standard error will be captured in the logs, and these logs will be sent through from Docker to Kubernetes, and Kubernetes will then keep these logs. It's very simple. It works nice while developing, but it does have its downsides because its records are basically line-based. So if you have one line, that's your log message. If you got a traceback that you got in your logs, that spans multiple lines. That's kind of no longer one logical. Once it's gone through the Docker and Kubernetes logging, that's no longer one logical line. Oftentimes the sort of log aggregation that might be running, that you probably your operations will probably start running once they deal with lots of logs. We'll try and join back together these records into a single record. But the thing here is that even though it's just standard out, you want to make sure that it is configurable. It's up to you, depending on how your operations manages things. So if they want to send all the logs to something like the Elk Stack, Elasticsearch, Logstash, and Kibana or something like that. So if they want to index it, search it, and make it searchable, all that sort of stuff, that kind of gets built on top. But you still want to give the option to the operations to configure their logging, and so you don't want to bake that completely into your application. So it's often very useful. I prefer it as command line arguments. You can stick things into the environment variables as well. But yeah, make sure to sort of make it configurable so your operations can choose what they do there. The other thing is, like, don't skip using your library, using logging libraries because it's just standard out. The logging libraries, just to get things going on standard out, are very easy to set up anyway. It means you straight away get your different log levels that you can use. All logging libraries are basically kind of wrappers around the horrible amount of global state that it's quite terrifying. Pick the one you like most, I would say. Some handle the global state in different ways. The thing I'm showing in the middle block with the logbook example is sort of kind of leads on to the next step that you might want to take with logging. Is once you're using a logging library and your operations have started moving to a log aggregator, you might actually want to, instead of going via the Docker and Kubernetes route of letting your logs being captured, you might actually want to start bypassing and start things directly into your log aggregation via something like Graylog or systemd. You could set that up to send. So you can add your additional logger log handlers to your logger library, and in that case you probably want to put the exception logging wrapped around your main function basically, because that will actually allow your whole exception to be sent as one single log record, rather than if you just let it up to Python to bubble out, it will end up on the normal Python handler will print it on standard out again, and it goes back as a bunch of unrelated records again. The last one, struct log, I think is very nice, especially if you're aggregating just lots of things, because it allows you to put a lot more machine parsable data in. So it's kind of it's kind of a nice wrapper around things as well. Yeah, so that's pretty much everything around logging, I think. So basically, yeah, standard out is not amazing, but using a log library allows you to evolve towards better log record handling. Next on, I would like to talk about the health endpoints that Kubernetes kind of provides. The thing here that we're trying to address here is when your application starts up, it might be initializing some data, it might be contacting various other things to collect data or whatever. But between process start and being ready to accept connections, this is obviously in the case your application is one that receives connections. There is a non-finite time. Unfortunately, as soon as your application starts up, your pod gets created in Kubernetes. It will be, if you have a service pointing to it, which you need to accept your connections. So as soon as that happens, traffic will start flowing towards you. If you haven't opened your socket yet, then those connections are just going to get connection refused, and you're losing requests basically. So the idea here is that you tell Kubernetes to wait to add your pod to the service as one of the handlers of that service until you're actually ready to accept connections. And they do this with a readiness probe. And there's various probes, various types here. Basically, the three types that they support is a TCP socket, an HTTP request, and a command to execute inside your container itself. The last one is not always terribly useful, I find, but the first two are very useful. So if you have, if you're for the TCP socket example, which is the top one here. If you have, if your service basically opens a socket for whatever, maybe 0MQ, gRPC, whatever, something like that, if it directly opens the socket, once the socket is open, basically you can use your main listening socket as for this probe in this case, because once the socket is open, connections will start to be able to be made. They'll queue up in the kernel until you call accept on your socket. So it's a very kind of useful probe. So and in this case, Kubernetes will, when you start the pod, it will try the port. If it's not ready yet, it will just wait. You can again configure this more detailed, how often to try and all this sort of things, how long to wait. If you're having a service which handles HTTP, that's even simpler. You can just add basically another route to your API that you got. It's kind of okay to just this health set route basically. So this configuration will do a simple plain HTTP request. You're probably fine with plain HTTP because, as I said, you have your reverse proxy already handling HTTPS, etc. in front of that. And the other thing is, because you have your reverse proxy in front, you don't have to worry about putting that health endpoint on a different port really, because your reverse proxy is not going to route any requests to that endpoint anyway. So users, if you're accepting direct user requests, users are still not going to see that endpoint because of your reverse proxy. So you can just do that in line with your main request, and that gives you a very good a very good sense of when your application is actually really handling your requests, because there's nothing special anymore. That kind of brings us to the next step on that is kind of liveness checking on this. It's another. The idea here is that if your application hangs or something like that, you don't want it to be included in the set of endpoints for that service. This kind of depends on your application. I mean, oftentimes you shouldn't really just randomly hang because you don't know anything. If you can, you should just crash and raise an exception and crash, basically. But if you do want, it's most useful probably if you have an HTTP service or API or something, because then you can just handle it in line, and that kind of gives you that guarantee of, yes, I'm handling requests in line. The exact example here, I'm not sure. Cat is certainly not a very practical example, but it just shows how that third kind of live probe. They're basically the same three types of probes that you have for readiness that you can use here as well. The one thing to look out with doing your HTTP requests in line is that you do have to balance it off. Like if your requests are queued and taking a bit too long, so you have to check that your timeouts, etc., on your liveness probes are okay, because otherwise you might still be handling requests. But Kubernetes then decides that you're taking too long. There's lots of trade-offs and tuning to be done there. So it's kind of, it can be useful. It's a more advanced kind of probe or health endpoint to add to it. But it does kind of lead on to safe pod termination in a way, or container application termination. Because it is something to kind of think about, because basically what Kubernetes will do when you're asked to terminate, so say a node, the node you're running on is taken to maintenance, so Kubernetes will kind of shut down all the pods on that node. That's not a problem for your application, because your replica set or something should be making sure that new pods appear somewhere else. But your pod is still healthy and servicing requests at that point. So for a pod or your application that's servicing user requests, what happens is basically it will send you SIG term. And in Python normally you get keyboard interrupt for that. So you will want to register a signal handler for it. So you can do that gracefully instead of just straight away crashing. Once you sort of in your signal handler, you can wrap that up more nicely. You can say, I'm going to shut down. As soon as you've got SIG term, you've basically already been removed from the service, so you're not going to get new requests, but you might still have requests currently queued up. So you want to finish your queue that you're running on. Make sure all your requests are handled, so you don't drop any of the requests, and only then carry on shutting down. Then the last kind of step into this is kind of monitoring, or maybe I think more of it as application instrumentation. So monitoring-wise, there's already a bunch of kind of monitoring that operators can do out of the box with Kubernetes by running stuff like CAdvisor or something. They'll have an idea of your container and resources it consumes, etc. Prometheus is a different project that is also part of the Cloud Native Computing Foundation. It's quite popular at the moment, but it allows you to basically instrument your application in various ways. This is a very, very short example, basically. Its architecture, its monitoring architecture of Prometheus is kind of I find it very similar to SNMP actually, but just with current technologies. It runs that we currently understand better. So it uses TCP, which is more reliable or has more guarantees than UDP. But it's still very much a poll-based kind of, the server goes around to all instances that it knows, and it goes and does a request and gets all the metrics down. Despite it being HTTP, the actual wire format is quite special. It's either some text format or it's protocol buffers, I think. So it's easiest to just use a client. They have an official Python client, which this is a very primitive example of. And it basically comes with various kind of instrumentation things. So you can have counters, you can have gauges. Again, if you've ever used SNMP, they're kind of very similar concepts. Yeah, it's just a bunch of metrics, and they can come around and scrape. In this example here, just using some counters, you define the counters on the fly, which is very convenient. And then you have things like context managers or decorators, etc., to help you with various things. That's kind of everything about. Yeah, there's a lot more obviously that you can do with data instrumentation, but that's kind of the sort of the next step, I guess. And that's just about time, I think. So thank you very much. I hope that was useful. And if you have any questions.